Question 21. The diagram shows a vertical cross-section ABC of a surface. The part of the surface AB is smooth and A is 2.5 meters above the level of B. The part of the surface from B to C is rough and is at 45 degrees to the horizontal. The distance BC is 4 meters. The particle P of mass 0.2 kg is released from rest at A and moves in contact with the curve AB and then with the straight line BC. The coefficient of friction between P and the part of the surface containing BC is 0.4. Find the speed with which the particle reaches C. Okay, so this part of the surface is smooth and the other part B to C is rough. So I'm going to apply the work power principle on the first part of the journey AB and then work power principle on the second part of the journey BC separately. Okay, so from A to B, work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay, it's just a particle, there's no driving force. And in part A to B, there's no resistance either. Okay, so it's just energy loss is equals to energy gain. Energy loss would be the potential energy loss because height is dropping. Energy gain is going to be the kinetic energy gain because the speed will increase from rest to another value. Okay, so potential energy would be mgh. So mass is m, no, it's 0.2. G is 10, and the difference in height is already given 2.5. Difference in vertical height is equals to gain in energy. So I'm going to do half and m common, and then bigger speed would be the speed at V, speed at B. So V squared minus initial speed was 0 squared. Solve this and get the value of V, which should come out to be 5 under root 5. Sorry, 5 under root 2 meters per second. Okay, so the speed here is 5 under root 2 meters per second. Okay, now I'm going to apply work and energy principle on B to C. So from B to C, same formula, work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay, again, there's no driving force. Energy loss is going to be the potential energy loss again, mgh, so 0.2 times 10. Now the difference in vertical height from B to C is this, which is 4 sine 45. Is equals to work done by resisting force. Now there is resistance mentioned in the question, and also we were given a coefficient of friction, which is mu. Okay, so as the particle falls down, there will be a resistance, and that is equals to mu times R. Okay, now the resisting force of resistance is mu R. So you need its value, and then you will multiply it with the distance it covers, which is 4 meters, to get the value of work done by resisting force. Okay, let's find this resisting force now. It's going to be mu is given as 0.4 and we need R. R is the normal contact force, and in this case, it's going to be opposite to the weight component, which is mg cos theta. This component is mg cos theta. So R would be equals to m, which is 0.2, g, which is 10, and cos theta, which is cos 45. So what do we get? 0.4 into 0.2 into 10 into cos 45. It's coming out to be 36. So 36 times 4 would be the work done by resisting force. Okay. Plus gain in energy is going to be the gain in kinetic energy. Half times m is taken constant times the speed at C, let's call it V, minus the speed at B, that was 5 under root 2, and you square these speeds before subtracting. Okay, Now again, you make V square the subject on your own, and you should get V equals 9.16 in the end. Remember to take square root because first you'll make V square the subject and then you'll square root both sides to get V. Here, there's a mistake. I've noticed this does not come out to be 36. I don't know why I got 36 earlier. It's a very small value. It is 0.4 into 0.2 into 10 into cos 45 is 0.5656. So use that here. Please disregard what I said earlier. It's going to be 0.5656 and then you use that in this equation and you should get the same correct final answer.